Okay, it's 9 o'clock on the button, so I think we're going to get started. Just make your way to your seats if you don't mind, please. And anybody who's stuck in the hall can come on in, please, and we'll look forward to getting going. So this morning, the next presentation we have to offer at 9 o'clock is Contec Construction Products. Our relationship with Contec started with Contec Stormwater Treatment. It's the leader of on-site stormwater, and we first introduced it, Shaw Precast introduced it in 2003. Since that, we've installed more than 175 CDS stormwater treatment chambers in Atlantic Canada. The units range in size from a smallest unit treating 20 liters a second up to a unit that will treat over 700 liters per second. So we have quite a range of models available to offer. Shaw Precast Solutions is also pleased to have supplied the largest unit ever in Atlantic Canada. It's a 5668, which treats 538 liters per second, and it's installed at the Russell Lake Commercial Development. We're also pleased to provide following services and/or technical reports with all installations, sizing and estimate packages based on site-specific hydrology, model efficiencies, and TSS removal rates based on the information that you provide to us. This morning we are pleased to have with us Mr. John Stryver, P.Eng. He's Contec's Regional Project Consultant for Massachusetts. John has been with the company for over 10 years. He has been instrumental in promoting stormwater quality in the Southwest market, where he has lived most of his life. For the past 5 years, John's focus has been on all Contec products, the Massachusetts market. John earned a BS degree in civil engineering with a business management minor from San Jose State University, and John is a licensed professional engineer in California and in Maine. He's a certified professional in stormwater quality and has over 15 years' experience in the industry. In addition to the stormwater treatment chambers that Shaw currently offers, John's also going to talk about a couple other products that we're interested in making sure that you know are available. And a few of those are media filtration, some urban green stormwater solutions such as underground containment and rainwater harvesting, and again, continuing our theme from the last presentation, erosion control. Erosion control certainly seems to have become a more prevalent topic in the last couple of years for us, particularly in our coastal areas. So Contec has some erosion control products that they're going to inform the group on. So John, I'm going to turn it over to you.
Good. Thank you. Thanks, Rylan. Just before we get started, how many engineers do we have in this room? I'm assuming most. Contractors? A couple contractors. Any regulators in here? No? One? Two, maybe? Okay. So as I get started here, I wanted you to note the contact information up on the screen here. Jennifer Knowles, I don't know if she's in the room here. She is our stormwater design engineer, and she works in the Canadian market. She works with Rylan. So those are the two contacts for this region here. I will be here all day, so if you have any questions afterwards, we can discuss some of these topics at more length, the design and whatever else you wanted to learn about. So Contec, just as a quick overview, Rylan kind of summarized it a little bit there. Contec's been around for over 100 years. It's had a couple of different names. It started out as Armco Steel, but today we provide a wide array of civil engineering solutions to folks like yourself to meet the regulatory requirements that are out there. And if you kind of look over the history, we've provided over the last, say, 110 years, various solutions, starting with pipe. Contec started out as a pipe company, and that was back in the late 1800s. And in the 1980s, we branched off to other areas. This is one of our latest innovations. It's called Duramax. It's a steel-reinforced, high-density polyethylene pipe. And you might think, well, what's the point of having steel-reinforced, high-density polyethylene pipe? It's got a couple of advantages. First of all, number one, we use a pressure-rated resin. So this isn't your Ashto M294, your standard plastic corrugated pipe. The ribs in this pipe are made out of steel, 80 KSI steel. And the profile on this pipe is about an inch. I speak in inches and feet, so bear with me on that part. But is about an inch. So a 60-inch diameter pipe or a 5-foot diameter pipe is going to have a very thin profile. This allows us to use this particular product in various applications. In particular, One I'm going to talk about today is rainwater harvesting. So when we get towards that, at least you'll know what this particular material is. But because it's a pressure-rated resin and it's a different subclass of high-density polyethylene, the joints that we use for this pipe can be the fusion welded joints. So we can get over 30 psi at a joint. The typical bell and spigot, the steel-reinforced bell, steel-reinforced spigot, allows for a very tight connection with a rubber gasketed joint of over 15 psi. So this gives us a little bit more opportunity to branch off into areas where we really need to have a bottle-tight system. And if you're dealing with contaminated rainwater or contaminated groundwater, you won't have to worry about infiltration or exfiltration at those joints. So keep that in mind as we move through. These logos here are the brand names that Contech has had over the years. The one we're really focusing on today is Urban Green. That's Contech's new brand for the stormwater division that we work with. And so I'm going to talk about that mostly today, but I did want to show one thing to you with the soil stabilizations area. We have access to, Ryland has access to a array of products that are concrete articulated block systems called Armor Flex. Armor Tech is a company that was purchased by Contech years ago. These blocks have a wide array of uses. Anything from dam overtoppings, we've used them in boat ramps, channel linings, your typical erosion control. And if you think of it from the perspective of using it on various projects, you can think of wherever you would use riprap, for example. This could be used in its place. It offers quite a few benefits. So number one, if you're placing them in a channel lining situation or an embankment protection situation like this, they are articulating, which means that they will conform to the contour of the embankment that you're setting them in. They're cable tied, so when you're setting them down, you get blankets, and we can make the blankets however long, however wide you want, so long as we can ship those. And they're set down with a spreader bar in either an excavator like this or a crane, depending on how big those blankets are. But you'll notice that these blocks are open cell. So open cell blocks have the added benefit of being able to vegetate. So here's 1 year later. This is what the embankment will look like. So we live in kind of a green world these days, and people want to see vegetation. So we've stabilized the embankment. We provided an area for vegetation. It's also a safety benefit as well. If people wanted to come down towards that water and they were dealing with large pieces of stone or riprap, it could be dangerous. So this is one option. It also minimizes the heat island effect. So the heat island effect is as water runs into the water and it becomes hot on a hot summer day over the riprap, that could potentially become a pollutant or an inhibitor for the fish. So we look at all those things. Dam overtoppings, this is another area we're very active in. These also can be vegetated. So if you wanted to have a green dam, you could still do that, but you've got the ultimate protection of the hard armoring on the backside of the dam. A couple of other applications is bridge pier protection. A couple pictures there. This is a sanitary landfill. This is a downshoot. You can line those as well. Now you'll also notice there's a product here called Ajax. It's in the same family of solutions that we have here. Those are used for energy dissipation. So you'll see in that picture down at the bottom, those are used for energy dissipation. You can also use them to protect the piers from a bridge. The way that they work is as water is going through them, little eddies are formed, and eddies will allow for sedimentation to accumulate there because there's little pockets of low energy. So it discourages scour. So as these, if you look at the applications, we've even used this on a beach application for a hovercraft to land. I mean, we can get kind of creative with how we use these, but they're very effective in how they maintain the ability to keep the soil where it needs to be. So in this picture on the left with the Ajax, that's the protection of the toe of a slope. So when you're thinking about protecting an embankment, it's also important to consider the toe of the slope, because if you protect the embankment but you have a hydraulic situation going and moving sediment down at the toe, you could lose the whole embankment whether you protected the toe or not. So these Ajax can be placed by hand. You can see this is a 24-inch block that this guy's holding here. We can make them up to 12 feet tall. So the large ones for like wave attack applications, to protect a pier, or a wharf. We've seen them in those applications as well. So they can get kind of large, and you can use them together as well in these applications. So that's just one area that we have access to here. And Contec does quite a few things, and Ryland would be happy to share some of those other details with you on the erosion control. But I'm going to move into the urban green and the stormwater area here. We're going to talk about different ways of dealing with stormwater quality and how we treat for pollutants, and also with stormwater management and what we do with that water once it falls onto our site. So as a civil engineer and a designer, you're thinking, well, okay, I've got this drop of water that's hitting my site. It can either be an asset or it can be a liability. And the best designs that you can come up with are to show that to your client as being an asset. So we have to figure out ways of doing that, and you can store it, reuse it, you can infiltrate and prevent discharge. So this is one example. This Chamber Max is a plastic underground detention chamber or retention chamber. If you use a lined trench, it would be a detention system, but usually we use these for infiltration. So these chambers are about 30 inches tall. They're very durable. Over the years, there's been a few plastic chambers come onto the market. What's great about these is they have a connected or an end cap that's molded with part of the chamber. So you don't have to spend a bunch of extra money to buy end caps for these. So you can see that the end cap right here. So what that does is that adds to the stiffness of the chamber. So when you load it, you have more resistance or more strength in that chamber to resist the loads over the top. So if you put this under a parking lot, you need a minimum of 18 inches of cover, and you need to make sure that you've got it protected properly with the backfill material. Usually they use a granular material. There's about 5 inches in between each chamber as a minimum. And you, of course, get the void ratio in between the chambers with the crushed stone. So a design would allow you to store a certain amount of water in the chamber and around the chamber to meet your infiltration requirements. So that will help you to limit the amount of water leaving your site once it starts to rain. So when you're designing these, I don't know if you all have HydroCAD. Anybody use HydroCAD in this facility? This is a U.S. thing. A couple people. Okay, good. Well, we have two options anyway if you don't have HydroCAD. HydroCAD's a great tool, and all of our solutions are in there. But we also have a DYODS. It's a Design Your Own Detention System program. It's on our website, and it looks like this. So you can go on to contec-cpi.com, and the website will be up at the end as well. And you can lay your system out here. You can type in all the parameters that you have for your design, including the porosity of the stone and the layout, what it's going to look like, and it will give you all the information that you need to design this. Also, remember, at your disposal is Jen Knowles. I think she's at the booth now. Oh, there she is. She's done. Stand up and wave, Jen. So Jen is our stormwater design engineer, and she's the person that you would contact that could help you with these designs. If you struggle with this, or if you wanted to speak to a live person, she's always there for you, and she can help put these designs together. So when you're looking at a chamber, my personal opinion is that there's so many solutions, and I know that Shaw has a lot of solutions for underground infiltration as well, and this is one that you can have in your toolbox as, for maybe shallow areas. The thing is, you need to have 6 inches of stone below and above a plastic chamber for structural integrity. So these chambers are HS25 load rated, which means they can take quite a bit of loading over the top, but we do need to make sure they're protected with at least 6 inches of stone and another 12 inches of cover over the top of that to the bottom of flexible pavement. So underneath parking areas, these chambers work great. You can put them in landscaped areas as well, and they help you to basically take that stormwater runoff and infiltrate it and limit the amount that you have. So when you look at stormwater, the other thing you might want to consider is treating it. And I'm not exactly clear on what all the regulations are here, but I know where we work, you can't discharge any untreated stormwater. And the CDS unit is a great way to do that, and I'm going to kind of mention that. There's a couple of things, like when you look at the underground infiltration, you look at detention, you look at rainwater harvesting, you look at media filtration. It's always important to pre-treat your stormwater, because if you are going to infiltrate it, if you're going to filter the stormwater, if you're going to store the stormwater, you don't want to store all the other garbage that comes along with it, the fines, the phosphorus, the nutrients, the metals, those things. So there are ways to treat your stormwater before you either store it or infiltrate it. And the CDS unit's one way you can do that. Now, Ryland, do you use mostly inline systems here? Okay, so inline systems, they have an internal bypass. There's a great benefit there. You can minimize the number of structures you're using. We can also go offline with some of the larger structures. He mentioned one of the larger treatment systems that he's put in up here. But the CDS unit incorporates an indirect screening process. The screen that it has, I kind of relate it to a cheese grater. And if you step by our booth this afternoon, you'll see that the screen that it has is very unique. It's not like the screen on a window. It's not directional screening. You actually have water spinning around, basically tangential to that screen, and it keeps that screen from blinding. And the water, when it goes through the screen, has to take a turn because there's a cup on the outside of the screen, which changes the direction on the outside. So you really have water spinning in two different directions inside that system. Now, the screen isn't used to remove the fines, just so you're clear on that. The screen is used to remove trash and debris and big floatable items, and the CDS unit is really one of a kind in that it can remove all of the trash and debris, anything that's larger than the screen opening and screen aperture size, which typically is about 2,400 microns here. So cigarette butts and anything that comes in, if there's ever a requirement to remove those items from stormwater, this is a great solution because it's very cost-effective and efficient at doing that. So looking over from above, and this is a picture of what would typically be an offline structure, and I'll show one of an online structure as well, but the water comes in through that inlet, it's channeled into the CDS unit, and so the screen, this hairy-looking thing on the outside, this is your screen. So the water's coming in, it's spinning around, in this case clockwise, and then as it leaves the screen, and then exits the system up here. So in this case, this particular structure uses the screen as an orifice. The screen has a certain hydraulic capacity. It can pass so much water, and when it gets to a point where it can't pass it anymore, it's going to back water up to your inlet area, and you're going to have an external bypass in this case. So you treat what you need to treat, bypass the rest. So you get your first flush in the system where the pollutants are the highest, and then you bypass your cleaner water. So here's a look of the screens. We have two different sizes, and typically, like I said, we use the 2,400 micron screen here. When you look at the screen from the up, I'll call it the up channel or the down channel, you're going to get two different views of it. So that's the look of the screen. So if you run your finger along the inside of the screen, it's smooth one way and not smooth the other. So as the water passes through, the bottom left, that's what the water is going to see as it's moving through. It's moving through in either a clockwise or counterclockwise direction, however it's designed. And when it passes through the screen, it leaves in the opposite direction. And it's very important because what that does is it allows us to treat a lot more water without blinding that screen, because that screen is our orifice and we want to keep that open. So just another picture of the screen and what it looks like there. Lots of testing has gone. We've done lots of testing on the CDS unit. It's been tested not only in the laboratory. We use certain standards to test the system, not only for performance of removing the fines, but also for the system's ability to maintain those fines and not wash those fines out, so scour testing. So it goes through robust testing both in the lab and in the field, and it's been verified by a lot of national standards in the U.S. Really, this is the only system that's been through some of the most robust testing that's required in the U.S., a system called TARP with NJCAT. And if you wanted to learn more about those, I'll be happy to talk to you about those offline. But those are two of the most difficult field testings and verification systems to get, and this is one of the only systems that has it. So maybe one of the more common structures you'd see is this inline system for small sites. I see this a lot down in Massachusetts, where I spend a lot of my time. And these systems here, they have an internal bypass. You don't need an external structure to take those heavy flows away. You can do that inside the system. And looking from above, this is what you're going to see. And you'll see this if you look at our working model that we have in our booth. But the water will come in through this diversion weir. This is your inlet structure. And it's going to swirl around. Again, you've got the same type of a system. You've got a sump to collect the fines. The floating trash and debris is going to be captured inside this chamber here. And then as the water passes outside, it's going to spin around in the opposite direction. And the outlet pipe is underneath this oil baffle. So we're able to capture the oils, the greases in the external chamber, the trash and debris in the separation chamber, and the sediment is going to be collected in the sump. Now, one thing that's also important to note on a CDS system is it can remove neutrally buoyant floatables, and it's one of the only systems that can. So if you take like a plastic shopping bag, it's going to be moving around in the water, up, down, sideways. It doesn't care about gravity. It moves with the current. Those elements are difficult to capture in hydrodynamic separators because they can typically escape the system by moving through and following the path of the water. In a CDS unit, that's not the case, and they'll be captured here. So this has a lot of extra benefits. We can also go with a graded top if you wanted to use these in a parking lot area for the smaller units. We could take sheet flow right from the parking lot and drain it right into this system. And essentially, it's the same unit. The only difference is with a grate, the water is going to land on this platform, and that green circle there, that's a lid. It's a sealed lid that gives you access to the chamber for maintenance. But when it's closed, it's sealed off. So the water that lands on this platform runs into your inlet bay and then circles back around. You still get the swirling motion. And all of the products we have for hydrodynamic separation have a swirling component. And that's essential because with a swirling component, we're forcing low energy towards the center of that, and the fines are moved into a conical pile at the bottom of that sump. Without that, we're nothing but a baffle tank. And there's a lot of products out there that have manholes that are baffles. They just need to be a lot bigger. So using a system like a CDS unit, you can achieve a much higher level of performance in a smaller round structure because of the swirling motion that we have. The other thing that's nice about the CDS unit is it allows for multiple pipe inlets. So if you're designing a site and you've got a junction manhole, gone are the days where you have to use a junction manhole to join your pipes and then put something downstream. This will save the cost of that if you can make it work. And the rule of thumb I use for this is if you take that manhole, cut it in half wherever you do, half of that inlet, or half of the manhole can be used for inlets, and the other half can be used for outlets. So as long as you can make it work that direction and you can get your pipes in there, and Jen certainly can help you with that design as well, but we can accommodate multiple pipes. Multiple pipes and graded inlets. If you have a system that you want to take some sheet flow from the parking lot and you've got a pipe coming in, we can treat all that. So that's a great benefit with a CDS unit. Very few systems can do that. When you move to offline systems, I show this to you just for kind of order of magnitude. We've come across a lot of projects over the years where an engineer has a large site. Instead of having regional treatment devices, which means the owner then has to treat at 10 different spots, let's say, with a larger CDS unit, if you can bring all of your treatment to one area, if your site's designed that way, you can treat with a larger structure. Sometimes that's more efficient and effective, and we look at all the options, but it certainly is more cost-effective from a maintenance perspective. So these larger units, they have, again, offline bypass or diversion weirs, and they will treat larger amounts. The screens can be pretty much as large as you want them to be. I mean, we did one I'll show you in a moment where the screen was custom designed, and there was a truck parked in the middle of it as they were building it. It's a very large system in Southern California. And so, treating up to 300 CFS or more is definitely a possibility. I don't know if your sites get that big here, but in Southern California, we've had a few instances on projects, especially highway projects, where they wanted to treat larger amounts. So this is one here in Southern California that treats 178 CFS, a very large system that was designed to remove basically the trash and debris, although we're also getting other pollutants as well, off of a stretch of highway in Southern California. So it can be designed, again, as large as you need it to be or as small. Typically, you'll probably see mostly the small systems for your projects. Now, maintenance is important. If anybody tells you they have a maintenance-free product, roll your eyes and walk away because, or run, because those systems, there's no such thing as a maintenance-free product. If you're collecting pollutants, they have to be removed somehow. And if you don't ever maintain these systems or really any system, what happens is you're going to go into bypass, and then all of a sudden your treatment device is ineffective. So we want to make maintenance easy. So when you pop the lid off of a CDS unit, you're going to see the collection of all the great stuff that either people have thrown from their cars or have come from their cars, and the fines and all the different things, leaf debris. and it's quite, it can be quite a mess. There's a couple of ways you can maintain. The number one way that people maintain these structures, they just vac out the entire treatment chamber. And the bigger the unit, obviously, the more water is going to be in there. The other thing is, if you're using these for debris collection, there is an option for a net or a screen that can be lifted up out of there and emptied. And you see that in the bottom left picture. So typically, again, the vac truck is what's used to remove the fines. We talk about total suspended solids. We talk about oils and greases. That's really the best way, is using a vac truck. So before maintenance on the left, after maintenance on the right, that's what it should look like. Very easy to get in there, unobstructed access. You don't need to actually physically get in there. You just need to put the stinger of the vac truck in there. So no confined space entrance requirements or anything of that nature. So when you're designing a treatment device, whether it be this or a filtration system, which I'm going to show you as well, Jen is the person that you would contact. There's really three ways that you can do that. Actually, you can contact Rylan as well. You can submit a project information worksheet, which basically outlines the needs that we have for designing the site. You can call Rylan. You can call Jen. You can send an email. And there's a few things that we need, which they'll be happy to share with you, that you can send us so we can get that design started for you. Once the design is completed, we may look and say, hey, there's a couple ways we can do this. Here's your proposals, and you can go from that direction and see which way you want to go. So that's hydrodynamic separation. That's what when you have total suspended solids or fines that you need to remove, you have some oil and grease, some trash and debris. What happens if you have a site where you need to remove phosphorus? What happens if you have a site that you need to remove metals or non-settlable solids? Not all fines will settle. Quite frankly, some of the clays that you'll see on site, they're going to make your water murky, and they're going to go right through a hydrodynamic separator. Well, some regulations will dictate the removal of some of those elements. So then you have to move to a much more robust type of treatment for stormwater. The media filtration system is a filtration system designed by the CDS family, and it's designed to remove those pollutants of concern. Lots of testing, again, on this system as well. But the way that this system is designed to work, as the water will come into this vault, there's a certain number of cartridges. Each cartridge has a certain treatment capacity. That vault will fill. This float right here will rise once that water reaches that point. When that float rises, it opens up a valve and allows the filtration process to begin. So then the water will pass through the filter cartridges, through the center core, which is the outlet for each cartridge, and it will leave the outlet pipe as treated water. So this is what the cartridge looks like when you break it down. The cartridge has a stainless steel screen around the outside of it to keep the filter media in. And I have some samples of filter media at our booth if you want to stop by there and take a look at those. The media ranges from perlite to zeolite, granular activated carbon. We have leaf compost media. We have something specifically for metals. We have a media that will remove phosphorus, which is an adsorption process, which I'll talk about. So there's a lot of different things you can put in here, and that's where when we look at the pollutants of concern, we want to know what is it that you're trying to achieve with this design. So to give you a better feel of this, hopefully this animation will work. I'm going to show you an animation of this system working here. So again, breaking the system apart, water starts to come into the treatment device and fill the cartridge bay. As the water is rising up in the cartridge bay, it's submerging the filter cartridges. It hits the float. The float rises, opens up the valve, and allows the treated water to pass through the core of the cartridge and exit the system. So again, as it moves through the cartridge, now that float plays an important role because it allows the cartridge to be utilized from the top to the bottom. We don't want to start filtration before the water hits the top of the cartridge, because then we're not utilizing the full extent of the cartridge. So what you didn't see as that animation was ending is the drain down process. So as the water filters through those cartridges, it's going to start to drain down. That float will drop, shut off that opening, and it'll wait for more water to come in to fill that up again. So it may go through several cycles during any given storm event. But what that does is it allows us to remove some of these pollutants of concern that you just can't get out in hydrodynamic separation. So why filtration? We've kind of talked about this. If you've got requirements for the treatment of stormwater in such a way that you just really can't get it with a land-based system, with infiltration, if you aren't allowed to infiltrate certain pollutants, filtration is a great way to do that. There's flow-based, there's volume-based, lots of different solutions that Jen and Ryland can talk to you about. Very easy to install. They're actually very easy to maintain as well. And there's two ways to do it. Typically, you can go in and either remove the media from the cartridge and repack it, or you can have us come out and exchange the cartridge for you. So it's a cartridge exchange program. We'll come out with however many cartridges you need. We'll swap them out and take the old cartridges back or the spent cartridges back, recycle the material if we can, repair the cartridge if it needs to be repaired, and then fill it and put it back into service. So when we look at the design, we look at the footprint, the pollutants of concern. We need a certain hydraulic drop to make the system work. And then we choose a configuration that works, whether it's a vault, a manhole, a curb inlet, whatever type of a system that you need, we can accommodate the configuration for you. So I talked about nutrients a little bit. In Massachusetts, we have TMDL, which is a limitation on how much pollutant a receiving water body can receive in a day and still be healthy. We have that for phosphorus. So we have to design systems to remove the phosphorus to a certain level before we can discharge into, say, the Charles River. There's TMDLs in Southern California for trash. CDS works great for that. There's TMDLs for sediment in a lot of areas. So depending on where you are, you want to identify your TMDLs or your regulations that require you to remove certain things. And we can remove things like nutrients. Metals is another thing. Zinc, brake pads. You'll get a lot of zinc and lead from those brake pads and on the roads, and we can remove those as well. Eutrophication is something that we deal with phosphorus. Algal blooms on rivers and waterways that will basically remove the oxygen so the fish can't survive. Algae is not a good thing to have on a river, and it's something that we can deal with a media filtration system. Typically, the regulatory requirements for phosphorus are 65% removal. Does anybody have a phosphorus requirement for removal here? It's just starting to hit the U.S., and I know a lot of agencies are looking at it in other parts of the world, but you may see it at some point. Phosphorus comes from a lot of sources, not just from people over-fertilizing their lawn. And with phosphorus, you can't filter something that's completely dissolved, so we need some type of an adsorption process. So we take the particulate phosphorus and we filter it. So to get total phosphorus, we need to get, on the left, the total dissolved phosphorus and the total particulate phosphorus. Particulate phosphorus is fairly easy to filter out. The dissolved phosphorus is the tough part. And so we use a adsorption process to partition the two to remove a total phosphorus level of whatever desirable rates we need. And the adsorption process is achieved through a coating that we put on the perlite media of alumina, which allows for the connection between the alumina and the phosphorus, the dissolved phosphorus. So the smaller the media, and we have different gradations of it, the smaller the media, the more surface area you have of alumina, and the better your adsorption rates will be. Again, but there's a side note to that. The finer the media, the lower the filtration rate. So you're going to have to have more cartridges or store more water and let it come down through the cartridges at a slower rate. So just a couple of pictures of what that media would look like. The finer gradation there on the right, greater surface area, again, lower flow rates through those filter cartridges. So here's just a quick summary on it. A lot of testing's been done on this. Contech has a history of being very conservative in their comments. And I appreciate that because I know there's a lot of manufacturers that make some pretty outrageous claims about what their systems can do. When we look at phosphorus, you can say, well, I'm going to remove 65% phosphorus. Then you have to assume that you have a certain percentage of dissolved phosphorus versus particulate phosphorus. Instead of making that assumption, knowing that we're going to get most of the particulate phosphorus, we focused our testing on dissolved. So if we want to say we're going to get 65% of the total phosphorus out, we would need to show 65% dissolved. And Contech was able to show over 70% of the dissolved phosphorus being removed. So if half of your material is particulate and we're getting most of that, and the other half is dissolved and we're getting 70%, you're going to expect to get over 70% of the total phosphorus removed. And that's no different than what we would do with other pollutants of concern as we look through. So these are an example of some of the media that we have for the media filtration system. We can combine the media like that ZPG is zeolite, perlite, and granular activated carbon. Those media can be combined together to remove a wider array of pollutants of concern. And those are dictated by your site-specific needs. And the biofilter is another product that we have available, and it incorporates not only biofiltration through the root of the tree and the root box of the tree, but also can incorporate it if you want filter cartridges. So a urban green biofilter in low-impact development applications is typical for taking water right at its source. If you line the street with trees and you put these systems in, it'll take the water right from its source, infiltrate that water through the soil, and there's an underdrain. If you can see the underdrain there. And then it will discharge that filtered water. Once that soil becomes supersaturated, it's going to spill over into the secondary bay, which can have the ability to put filter cartridges in there, which we just talked about. You can put a couple cartridges in there to get secondary treatment. Once those have hit capacity, you have an internal bypass. So you don't need to have an offline tree box filter. It'll do everything that you need inline. And there's certain flow rates that go along with this system. But the typical design would be a curb inlet with the tree box filter. And there's many varieties of these now. You don't have to have the filters. You can do it without the filter cartridges. You can do larger boxes. We can have open bottoms. I mean, the designs on this are really kind of endless, however you want them to look, and then we can design around those needs. And then the last thing I want to talk about here this morning is rainwater harvesting. Has anybody crossed this bridge and gone down this path yet up here? Rainwater harvesting? Couple? Okay. Rainwater harvesting, what about LEED? How many people work on projects and trying to get LEED credits? Okay, now there's a few more people. When you're talking about LEED credits, basically what you're trying to do in a design is you're trying to purchase either a tax break or come up with a sustainable design that meets certain requirements that LEED has outlined. Rainwater harvesting is a great way, at least in the U.S., it's a great way to get points for LEED. And there's two schools of thought with it. We're going to be talking about using it as a runoff reduction tool. You can also use it for irrigation. So when you look at the rainwater harvesting, the traditional rainwater harvesting would be, using it like a cistern. You're storing the water, you're reusing it. But with the definition with LID, or low impact development, when you're trying to make a small footprint on your site, you're also using it. It has a side benefit of reducing, or even in some cases eliminating, post-construction runoff, which is where all those pollutants come from. So that's what we can design this for. So it can be kind of a two-prong approach to your design. Number one, I mentioned this before, pre-treatment is essential. You don't want to be putting sand and grit and trash into a system that has a pump in it if you want your pump to last. Okay, so pre-treatment's essential. We can do that with the CDS units. Something you may not have seen, that little guy down there, that's like a wall-mounted type of a system. We can do even downspout CDS units, little tiny guys, to remove these pollutants that might come through, to make sure that water that you're collecting and pumping then is free of debris. An underground cistern type of an approach, you can store the water in tanks. I've seen people use fiberglass tanks. I mentioned the Duramax pipe, the steel reinforced polyethylene. We use a lot of that on these systems. Concrete vaults, we've designed large concrete vaults with some of our different solutions there. So there's a lot of ways you can store the water. That's one little piece of it, and you can see As you go through, there's some other options using the chambers if you were to store water there, and that would be a lined, like a lined trench in there for storage, or the polyethylene, steel reinforced polyethylene. You could use concrete pipe. You could use a lot of different solutions to store that water. So these are some examples of the ones we've used. This is one in Redondo Beach. Got one in Bodega, California. This is an example of the fusion welded joints. These were tested over 40 psi, but in some areas they just won't allow any potential for exfiltration or infiltration, and that's why they would use a joint like this. And we can even do above ground metal tanks, something that would look like this, like a silo, but is storing water for future use. And as your creativity moves you, you can recommend other ways. There's lots of different ways to store stormwater and rainwater for reuse. One of the components in a underground cistern type of an application is disinfection. In most areas that I've seen, disinfection is, if not required, recommended, strongly recommended, because as water sits, it can breed bacteria. And who wants to have bacteria sprayed all over their site if you're using a sprinkler type system? Drip systems are also available and may minimize that, but disinfection can play an important role in making sure that water that's leaving the tank is free from disease. So there's controls. We've got a first flush diverter, so you don't want to take that first flush of stormwater, in this case, and stick it into the tank. You want to divert it to a treatment device and then either treat it, infiltrate it, or then take your secondary flows and put them into your tank. So what Contec can do is we can design a complete system right from the beginning with a panel that might look something like this. If you have a client that is looking to store their rainwater and reuse it, or looking for lead credits, a system like this can be designed on a skid. You can roll it right into the basement of a building. You can put it in an outbuilding. There's a lot of different places you can put these. We'll design everything from the electrical panel, the pump, to the valves, the tanks, everything that you need, including the disinfection, to be rolled onto this skid or wherever you're going to build it, and then you pipe right to it. You plumb right to it. So a couple of other examples of where you can locate these. Sometimes they'll put them underground or in outdoor enclosed structures. Again, design. That's where Jen will help you with that. She can come through with some basic information and get the ball rolling for you. With any information that you send to Rylan or Jen, very important if you could send a site plan. That way we know exactly what we're dealing with. Rim and invert elevations are important to make sure that we've got enough cover to make the system work. And then we can put a design together and propose something for you that will work on your site, whatever your site may look like. So our goal is to help you leave a green footprint on your site, and we can help you do that with a lot of the solutions we have. And in an hour, I can only cover so many, but I think these are the ones that would probably be most relative to what you guys are working on in your projects. So with that, I'm a few minutes early, and I'm happy to take some questions if there are any. Again, please visit our booth if you haven't been by. Introduce yourself to Jen and to Rylan if you haven't yet, and we can field some questions either now or since I've got a few minutes. Do you want me to do that, Rylan? Yeah, if there's any questions. That soaked right in, and everybody got every word of that, right? Okay. Well, I will be here today, so if there's any questions as we move through, feel free to come by and speak with me or Jen or Rylan, and I thank you for your attention this morning.
Thanks very much.